Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. Remember, R is fixed. So once the problem has been set, so for example, you could put a 7 into here and a 7 into here. Once you put a 7 into there, then the 7 stays fixed. So it remains like this. Or you could put a 0.34 into the R here and then into a R here. But just remember, R is fixed. Okay, so press pause and have a go. Okay, so to do this, normally we would look at this and then check that the limit as n tends to infinity of r to the power of n. Normally we would need to check that this goes to 0, but because when it comes to this, it's quite hard to tell. So we're going to ignore this step and then perform one of the tests. The test that we should use here is a ratio test. So with the ratio test, look at the absolute of the next term divided by the current term. Well, n is moving from 1 to infinity, and r is always, remember, r is always positive. Because r is always positive, then this thing here will always be positive. This thing will always be positive, so we can ignore the absolute sign here. So an plus 1 divided by an. Well, an plus 1 is this thing here, divided by an. That's the same as multiplying the reciprocal of an. That's this thing here. So now it's just a matter of tidying this up. So looking at this, you can always rewrite this as one block multiplying another block, and then this block gets cancelled out with this one here, and then group these two together. Group these two together. So it looks like this. So group these two together. So that would be nr over n plus 1r, and then don't forget these two cancelled out. So you've got your r here. So that's this r here, and then this bit here you can rewrite it as this. So that will then take you to here. So now you've got one block multiplying another block. If you look at this bit here, if you have something like this, a bubble to the power of another bubble, if this contains n, remember taking the limit as n tends to infinity. If this contains n and this contains n, and this one wants to move to 1, and this one wants to move to infinity, then it's problematic because you've got a bubble here that's moving because n is moving towards infinity. So you've got a bubble here that's moving towards 1. You've got a bubble here that's moving towards infinity. But here is a simple case because r here is fixed. Here it will be difficult because you've got this thing that wants to move to infinity, and then this thing here wants to move to 1. But here, this is a simple version. It is just a bubble that's moving towards 1, and then this is fixed. This r here is fixed. Over here it's more complicated because you've got n that's moving to 1, and then you've got this n here that's moving towards infinity. Here you've got to do something cunning in order to resolve this. But over here, r is fixed. So this thing here wants to move to 1, and then r is fixed. So the whole thing here will head towards 1. Now, if you find this hard to grasp, so what I'm trying to say here is that if you have a bubble that wants to move towards 1, and then this thing here is fixed, you can put a 27 to the power of 27 here. If this bubble wants to move towards 1, then the overall thing here will head towards 1. So if you have a bubble here, and then you've got some, even if you have to the power of 0.0039, say, if this bubble wants to head towards 1, then the overall thing here will head towards 1, even if you've got a weird power here. Remember, it's problematic when you have this thing and then this bubble here wants to move to infinity. This one here wants to move. The problem arises when this thing is moving and this thing is moving. In our case, you've got this thing that's moving and this is fixed. So our case is a simple version of this. This will present you with a lot of problems. This here is nice and simple. Now, if you find this hard to grasp, then get a graph plotter and plot. Well, remember, if you find this hard to grasp, so this is moving towards 1, this is moving towards, well, this isn't moving, this is fixed. So stick a number into here. Even if you put a small number, if you plot it on a graph, it will head towards 1. So as you move towards infinity, as n moves towards infinity, it will head towards 1, even though it's a weird power, a power that's less than 1. Now, if you do the same but stick a big power into here, let's say 9, and then put this into A, and then put this into A, then the overall thing, it will head towards 1. So the point is that even though the point is that the point is that the limit of this as n moves towards infinity, if this is fixed and this wants to head towards 1, then the overall thing here, it will be 1. It will head towards 1. So the limit of this whole thing here is really r times 1. So it gives you r. So let's go back to the very start. So from the very start, we wanted to investigate whether this thing will converge or if it will diverge. We would perform the ratio test. Well, when you perform the ratio test, for this case here, it will give you r. So what that means is, if you look at the ratio test, the theorem, compute compute this bit here. Well, remember, normally it's this, but because we're always in the positive realm, we can ignore the absolutes here. Well, if you compute this value here, in our case it's r. If r is less than 1, if r is less than 1, then the series will converge. If r is bigger than 1, then it will diverge. So if you put a number here that's less than 1 into here. So for example, if you put 0.73 into here and into here, then this r here is less than 1. So this series will converge. If you put in, let's say, a 9 here, if you put in a 9 into here, compute this value, it will then give you a 9. It will then give you a 9. And then this 9 here is bigger than 1, so this series will diverge. So the point here is that if you put in a number bigger than 1, it will diverge. If you put a number into r here where it's less than 1, then it will converge. Okay.